Just a quick note before we get into this video. In the last video, I suggested marking the oil pump gears. So just use a center punch or a scriber or something. As someone rightly pointed out, the top face of the gears do run against the oil pump cap, so a center punch is maybe not the best idea since it'll leave a little high spot. That's all, thank you. Okay, so here are the Tappet slides. These rollers ride up and down on the camshaft. These in turn sit in here, and both of these ride up and down in these sleeves. This is where the push rod sits, and the push rod obviously goes up and down, opening and closing the valves. Generally, these are all high mileage parts. You can expect to reuse all of this unless your engine's done really high mileage or has been run dry or something like that. Unfortunately, in this case, these rollers have suffered a little corrosion, just from condensation because the motor sat for so long. So I'm going to replace all of these with new ones. A word of warning if you need to replace these rollers. If you can find genuine ones, that's great. Otherwise, buy them from Turner Engineering in the UK because they get their own rollers manufactured for them, because the aftermarket ones have a terrible reputation for failing. Apparently there was a large batch that were poorly hardened, and this happens. And a failure like this has probably taken the rest of the engine with it, so it's not worth the risk. Don't buy cheap aftermarket rollers. The Tappet slides are similar, probably less of a risk, but the aftermarket ones don't have a great reputation either. Someone posted this picture on Facebook just the other day, in fact, asking if there was a better supply available, either OEM or genuine. Unfortunately not. So I would prefer to use the original ones so long as they're in good condition, no scoring or anything like that. And these ones are all fine. Now in this case specifically, you'll note that 4 of the slides are nice and clean, 4 of them have a black coating on the inside radius. I think that black coating is a bearing material that Land Rover applied on the Tappet slides in earlier engines. These same slides were used right into 300 TDI. But I'm an idiot. I threw 4 of them into the ultrasonic cleaner without thinking about it and blasted the bearing material right off them. So the fact that the bearing material has gone from these 4 in itself doesn't really matter. These are fine to run in plain bronze, but the problem is these ones were made to accommodate that thickness. And now that that thickness is gone, these rollers won't be a precise fit anymore. Now luckily, I have plenty of Land Rover junk around here, so I managed to get 4 good old ones out of another motor. New retaining screws and sealing washers. Originally, these screws were wire tied. We're not going to do that, we'll just use Loctite. But if you did want to wire tie them, you'll probably have to reuse your old ones because the new ones don't come pre-drilled. And quickly, these washers you can see in the picture are fancy washers with little rubber inserts. Your gasket set won't come with these. You'll get plain, thin aluminium washers instead, which are fine. We're going to be using Loctite on the threads, which also acts as a seal, so the washers don't need to be anything fancy. Installation is easy. Just slide the sleeve in. Oh, and I should point out that everything needs to go back in where it came from. So the sleeve, roller, and slide from number 1 go back into number 1, etc. Just put the screw in so it holds the sleeve in place for now. And then the roller. Don't drop it on the camshaft. And if you're reusing rollers, they need to go back in the way they came out. The original rollers had a recess on each side, and as per the service manual, the large side goes towards the front, so that's pretty easy. And then the slide. The slides say front on the side that faces the front, so that's pretty easy too. And then just tighten up the screw. Easy peasy. And that's it for the Tappet slides. Okay, so here's the situation. Generally, the crux of this operation is to push the old bushings out, push new bushings in that are reamed to size, throw everything back together on a new shaft, and you're good to go. However, in this case, some of these rockers have quite a bit of wear and tear on them. So we're going to have to address that. The pads themselves are quite worn, not terrible, but we need to do something about it. This is probably the worst one. But also, some of them have quite a bit of wear on the face that rubs against the spring. And I've laid this out to show you what's going on. So these posts are fixed in position. And either side of these posts, there are these thick hardened washers. And where the rockers rub against the washers, they're completely fine. The spring sits in between each pair and just pushes them apart. And these are rocking independently of each other. And the springs have just worn into the sides. And on some of them, like this one, the spring has started to tip in towards the center, so this actually tapers in towards the shaft in kind of a cone shape. And you can see if we look at the shaft, these stripes where the springs have been rubbing. It's not like it's affecting how the engine runs or anything like that, and it's probably taken 300,000 Ks of neglect to get to that point. However, we're here, so let's do something about it. Now, just a quick note here. This is a rocker out of a 5-main bearing engine. And if you search for these part numbers, they supersede to these part numbers. But these are not interchangeable. The oil feed comes via the shaft up through the bearing, and then there's a hole up inside here, and oil comes up through this tiny hole on the top, and also down a passageway through the back here. This is what lubricates the push rod, and the oil that comes up here runs down here and lubricates the top of the valve. And if you look at this newer style one, you'll see that that oil passage is different. It comes out on the snout. And that in itself isn't an issue. What is an issue is the fact that these are designed to work at slightly higher pressure. So when you put one of these in with 7 of these, you don't get any oil coming out of this rocker. And I appreciate that this hole in the front looks larger, so you would think more oil, but I have put one of these into the engine, and I can tell you that if you do that, you won't get sufficient oil out of these newer rockers. And maybe you could solve that problem by replacing all of them with the newer style ones. I don't know. I don't know if that would cause a problem elsewhere in the engine. I don't know. I think if you really have to replace a rocker, the safest thing to do is to find another old one. Either new old stock, or I think Turners sell refurbished ones, or just find a good used one. Anyway, we are fixing the ones we've got. And the first job is to strip these old rockers down, so remove the adjustment screws and press the old bearings out. And these need to be kept in their correct position because they match the push rods. I'll just point out that to replace the bearings in the rockers, you really need machine tools. You have to make little bits to press the bearings in and out, and then you have to ream or hone the new bearings afterwards. And if your engine has any mileage on it at all, you will have to replace the rocker bearings and the rocker shaft. So if you can't do it yourself, it's just a little extra cost for your engine machinist to do it for you. Very straightforward work for them. So, I quickly made up this aluminium arbor. Well, I say quickly, but I could not find a convenient sized piece of aluminium, so this in fact took me a really long time. Anyway, we're going to super glue each rocker onto this arbor and just lightly skim the damaged face. And I want to do this with a little bit of thought. I don't want the super glue to run through the oil galleries. We'll just put it on the back part there, and just the front part in here. Okay, That'll do it for this one. This one wasn't too bad. Some of the others are more gnarly. But that was a 5 thou cut. And then dissolve the superglue in acetone. This is the last one I have to machine, and this is probably the worst one. You can see where the spring's been sitting. It's really starting to wedge itself in against where the shaft would be. Okay, so those are all done now, all 8 of them. And now you can see there's a nice flat machined surface for the spring to start out on. So the next job we need to do is polish these pads. They are a little worn from the valves. They have little flat spots worn into them. And we need these to be nice and smooth so we can set accurate valve clearances. And I did seek advice on this. In fact, I took one of these down to the engine machinist and asked them about it. He said, yes, these are fine to polish by hand. Any worse, and they would need to be reground. This is a specific radius, so we can't just take this over to the bench grinder and make a nice smooth shape. That's not how it works. When they regrind these, they have a jig. They can set this up and rock it back and forth and maintain this radius. So just using some sandpaper on the edge of the bench, even pressure, keep it nice and flat. It doesn't take long. The marks are very shallow. This is 220 grit, by the way. Okay, that looks pretty good to me. It's a little hard to tell because I have stripy lights, but that's pretty smooth. And I think I'm going to go over this with a finer grit, and then ultimately I'll polish them all. Okay, next job, we've got to fit the bushings, and these need to be reamed to nicely fit the new shaft. This is easier said than done. The best thing to do is press the new bearings in and then take the rockers to your engine machinist who can hone the bearings to fit the rocker shaft perfectly. If you want to ream them yourself, you need to figure out a way to hold the rocker in a machine, which is not straightforward, and then ream them with an adjustable reamer held in a floating reamer holder. That would be the best way to do it. Now I happen to already have a 13.5mm fixed reamer, which is in theory the correct size. I don't have an adjustable reamer, and I don't have a good way to hold the rockers onto a machine. Let me show you how I've done this in the past. It's a bit of a workaround. So I'm going to press each bushing into this, and then run the 13.5mm reamer through it on the lathe. And I've sized this bore through trial and error so that the bushing ends up being a really good fit on the shaft after it's pressed into this. Now you can see here I've marked one of the jaws with some red marker. So each time I put this in to start with, there's a center punch on the front of this, and we start with that on the red jaw. I'll show you why in a second. I've got the lathe on its slowest normal speed, cutting fluid, and you might be thinking you can just do this by hand. Yeah, not really. A 13.5mm reamer in bronze by hand? I mean, try it if you want to, but you'll probably just waller out a hexagon, which is the bestagon, but not really what we want here. I happen to know that one pass is not enough, so what we're going to do is move this around one jaw and make another pass. So I'm using the slight inaccuracy in the 3-jaw chuck to cut a little bit more the second time. of oil so we don't get galling. Now, we have to make sure that this hole aligns with the hole inside the rocker. The bushing is just a smidge longer than the rocker, so we want to make sure it's flush or a little bit in on the side that controls its position. Okay, there it is. Pause. Rocker shaft information. These shafts tend to be undersized. This one measures 13.44 millimeters. That's why even if we could ream a perfect 13.5 millimeter hole, it would be too loose. But the end will be fat. That's because when these are made, they press a plug into the end of the shaft to close it off, and that splays the end of the shaft out slightly. So you need to carefully use your bench grinder or belt grinder or whatever you have to remove some material from the very end. Just make sure you stay clear of the first oil hole. You don't need to go that far back. If you don't do this, your bushings will need to be very sloppy so that they can clear that larger diameter. Oh, perfect. And virtually zero play. Okay. Again, this is not how I recommend anyone does this, but I got all 8 to a really nice fit with the equipment I had. Chef's kiss. I believe that all of these are the same casting, so if you really wanted to pull them all apart and mix them around, you could do that. It doesn't matter. 3 of them have studs sticking up that hold the rocker cover on, and of the other 2, you'll note that one has a screw sticking out the top. And this is actually a little peg. And that little peg goes into this locating hole on the rocker shaft to hold it in position in this direction. And there is only one. You'll see on the other end, no hole. So yes, it is correct. When you look in the top of one of these motors, there is an empty hole. That's how it's supposed to be. Now I think that the shaft is in every other way a mirror image. I think. However, the convention is that this post with the peg is towards the front of the motor. So this is towards the front. Now, of these 3 posts with the studs sticking up, one of these, the one that goes at the back of the motor, is the oil feed for the rocker shaft. If I flip this over, so that's the oil feed for the entire rocker shaft. Now, I've cleaned all of these up, but when you pull your engine apart, the other 2 will be absolutely plugged. So if you for some reason mix these up, make sure that the oil feed hole is clear on the one that feeds the oil. Alright, so everything has been thoroughly cleaned, the bench has been wiped down so there's no grit on it or anything like that, and we're ready to go. We'll start with the post that has the retainer peg in it, and these can be a little tight, but not in this case. And now one of the original washers. Have I done that the right way around? Let me check. Yes, I have not. Let me fix that. Drop of oil. And now number 2 rocker, which I believe goes on this way. We better add more oil. The spring. Now number 1. And if we are very, very lucky, the post will be tight enough that it holds everything in position. Maybe. These posts do clamp the shaft, but only when you install the bolts that go through into the head. So at the moment it's just sitting there, ready to ping off into my face at any moment. Okay, there it is. I'll put a clamp on it just for display purposes. Next, we have to put in the little adjuster screws. Make sure you look through these. I would say of the 8, about 5 of them were plugged solid. And these need to be kept in the right position because this has perfectly mated itself to the push rod. And the adjuster nuts. Actually, this one's a little mangled. I might rob a better one from somewhere else. There we go. And I've put all of these in their most upwards position, so the loosest position, just so nothing binds up when we squash it down on top of the valves. So we'll just get this out of the way and get the rest of the head ready. Almost there. So that's it. Next we put the head on and button up the engine. I'll see you back here soon.